13. The minute hand of a clock sweeps out an arc as time moves forward. From 3:10 to 3:30, what is the measure of this arc? Now, is it asking for length or is it asking for measure? Because those are two different things. Remember, humans have a height and a weight. Two different measurements about the same human. Arcs have a length and they have a measure. Measures are out of 360. Lengths are out of circumference. I knew right away that this wasn't asking for arc length. You know why? Because we didn't know the radius. If you don't know a radius, you can't find the arc length. I don't know how big this clock is, so I couldn't possibly find the arc length, but I can find the measure. So there's a few ways we could go about this. How many numbers did we travel? You see it now? We traveled 1, 2, 3, 4. We traveled 4 numbers. And then how many degrees do you travel when you go from number to number? Each time you go from number to number, you travel 36 degrees. So you can just multiply 36 times 4. Totally other ways to do that. I'm going to stop there though. Wait, no? Okay, 360 divided by 12 is officially 30. We traveled 4 spots. 4 times 30 degrees is where our 120 came from. The following circle graph shows how a typical household spends money on energy. In Houston, we spend probably a lot of money on cooling, not heating and cooling, mainly just cooling. Find the measure of each arc for the sector indicated. Once again, we're asking for measure. We're not asking for arc length. We're not asking for L. We're asking for M. Those are percentages. I don't know if you can see it. So really the only information you need to know here is how many degrees are in a circle. Because you take heating and cooling, it's 45%. And so we're just going to take 45% of 360. How much of all the way around did it use? It wants to use 45% of all the way around. You could set up a proportion, or you learned in algebra how to convert to a decimal. You could literally just find 45% of 360, which is 0.45 times 360. That's how you get all of those. You take the percentage of 360. We're going to do this again when it comes assessment time. You're going to make your own pie graph, and it'll be fun. Circle graph, pie chart. What I think would be a great idea in number 16 is to make up some numbers. So what I would do is make up a measure of the central angle. Let's make it up. Make it easy. Make it something that's divisible by 2 nicely. What do you want the central angle to be? No, 40. I picked 40. Sorry. You're too late. All right. So we're going to make up that the central angle right here, this one at least, is 40. So its arc would be 40. Because there's a circle inside a circle here. So we have to be careful. We're going to be getting smaller and smaller. I should have gone bigger. You're right. I should have gone a little bit bigger. Half of that would be 20. What would arc DE be? Yep. And then what would angle DFE be? Inscribed angle, half of its intercepted arc. Okay, now let's answer these questions, true or false. Which one is equivalent to the measure of AOB? So AOB is the one that we called 40. Is half of ACB. ACB is 20. What's half of 20? 10. No, that's not equivalent. What about the measure of ACB? It's 20. Does 20 equal 40? No. What about double the measure ACB? Double 20. Good. And the measure of arc AB. This is a central angle. This is its intercepted arc. So they're going to equal the same thing. This is a really good problem practicing inscribed and intercepted arcs and central.